bombshell. Fauci pushed for gain-of-function research in 2012, said it was worth the risk of the pandemic. Dr. Anthony Fauci, or as I call him, the Stormy Daniels of epidemiology, medical advisor to Joe Biden, defended controversial gain-of-function research in 2012 and said the research was worth the risk of a pandemic. So instead of me reading the article, I want you to hear it directly from Fauci because I believe this is the video that's up for discussion. Roll it, G.
Thank you for the opportunity to testify today on the NIH mission of performing biomedical research for the purpose of preparing for and responding to naturally emerging and re-emerging infectious diseases and the relationship of this type of research to biological security. As you mentioned in your statement, the issue at hand is the ongoing threat of the emergence of an H5N1 pandemic influenza and the research that was supported by the NIH to address this threat. The conduct and publication of the results of such research in the form of the two manuscripts that you mentioned has focused considerable public attention on the issue of dual-use research, namely research that is directed at providing new information critical to the public health, but at the same time has the potential for malevolent applications.
Okay, stop.
My written testimony.
So you need to listen to what he says. That's one sentence right there. He says it through. There's certain things in here that you listen. Think about what we've gone through for the last year and a half as you listen to this. There's certain phrases you're going to hear. There's certain things he talks about that you're going to sound like it sounds awfully familiar to what we just went through. So pay attention to everything he says. Go.
Testimony is submitted for the record, and in my few minutes of time, I will highlight just a few important aspects of this issue. First, the public health challenge. Seasonal influenza is an ongoing threat to public health worldwide and is among the leading global causes of death due to infectious diseases. Each year, influenza causes more than 200,000 hospitalizations and up to 49,000 deaths in the United States and up to 500,000 deaths globally. Yet influenza has animal reservoirs, especially in birds, and these viruses can undergo extensive genetic changes and jump species, resulting in an influenza virus to which humans are highly vulnerable. Such an event can, and historically has, led to global disasters, such as the one you mentioned, the prime example being the 1918 global influenza pandemic that killed up to 100 million people worldwide and caused enormous social and economic disruption. There is a clear and present danger that we will have another pandemic, since these viruses continue to circulate in the world and are constantly evolving towards pandemic capability, as we have seen in 1957, 68, and 2009. Over the last decade, a highly pathogenic H5N1 influenza has emerged among chickens. Rarely, the virus spreads to humans. Since 2003, approximately 600 confirmed cases have occurred in humans in more than a dozen countries shown in red on this poster. Nearly 60% of those reported cases have resulted in death. Should the virus mutate to transmit more efficiently to and among people, a widespread influenza pandemic could ensue. Indeed, nature itself is the most dangerous bioterrorist. And even as we meet today, H5N1 and other influenza viruses are naturally mutating and changing with the potential of a catastrophic pandemic. This is not a theoretical danger. It is a real danger. For decades, NIH has supported basic influenza research included on transmissibility, host adaptation, and virulence. The goal is to anticipate what the virus is continually trying to do on its own in the wild and to prepare for it. Such goals were pursued by the NIH-funded scientists Kawaoka and Fauci and could have important positive implications for pandemic influenza prediction, prevention, diagnosis, and treatment. Kawaoka and Fauci constructed variants of H5N1 avian influenza in order to identify which genetic mutations might alter the transmissibility of the virus.
Okay, stop.
In their study...
Okay, that is very important. when he continues to talk about increased transmissibility, that's what we want to pay attention to. What he just roll it back just a little bit, G, and listen, because this is the research that we're talking about. Is he describing exactly what happened in that lab? That's the question here. Go ahead.
Transmissibility of the virus. In their studies, they employed a standard influenza animal model, namely the ferret. This slide shows the basic design of the experiments in which the virus was modified to allow for aerosol transmission from one ferret to another.
Okay, stop. That sentence is the whole thing. That sentence is the key to the whole thing. Roll it back far enough to hear that whole thing again. Is what he describes right here, is this what happened in Wuhan? Go ahead.
H5N1 avian influenza in order to identify which genetic mutations might alter the transmissibility of the virus. In their studies, they employed a standard influenza animal model, namely the ferret. This slide shows the basic design of the experiments in which the virus was modified to allow for aerosol transmission from one ferret to another. I might point out that one of the causes of the public misunderstanding was the widespread belief that the virus that was transmitted by aerosol from one ferret to another actually killed the ferrets, when in fact that was not the case. We feel that these studies provide critical information, and it was important to determine if H5N1 virus that has this enhanced transmissibility would remain sensitive to existing anti-influenza drugs and vaccines. In addition, and importantly, knowledge of the genetic mutations that facilitate transmission may be critical for global surveillance of emerging influenza viruses. Yet, since transmissibility of a virulence virus was increased, this constitutes dual-use research of concern, or DIRC, which is shown on this poster. If a particular research experiment is identified as DIRC, that designation does not necessarily mean that such research should not be published, nor that it should even be prohibited in the first place. However, it does call for us, as you mentioned, to balance carefully the benefit of the research to the public health, the biosafety and biosecurity conditions under which the research is conducted, and the potential risk that the knowledge gained from such research might fall into the hands of those with ill intent.
Okay. So that's what he testified in 2012.